Okay. Page 103. Okay, so what I want you to do, okay, I want you to answer this question first, okay, on your whiteboard. Okay, so I hope you already have your own whiteboard. Okay, I can access the, okay, wait, I copy the link. What does it say, Manini? Okay, try to answer first the question for this one. Okay, before I teach you how to do. PT is equals to ML mm, mm. So the time 1.6 96. Mm, okay. Mm. For those the board that are still empty, teacher please help. Why? You cannot write anything in your board. Mm. Manini, try to exit first and join again. Try to exit first, then join again. Okay, 4.8 times 10 power of 6, 19,200 joule, okay. right? 40, 4,800 kg negative 1. Okay. Alright. Okay, so there's many of you got this one correct. Okay. So for those that I think maybe you have a problem to type, okay, in your board, I'm giving you 1 more minute, right, to try to answer first the question. Hmm. Okay, so let's see, right, actually how you want to answer for this question. Okay, right, good. KPG negative 1, okay. So let's see how you want to answer for this question. Okay, so for C1, right? So for C1 here, okay, said a solid substance of mass 0.02 kg is heated using an emission heater 240 volt 1 kilowatt. So diagram 11.2 shows the heating curve of the solid, right? So the first question, okay, so the first question asks you to find, right, calculate the specific latent heat of fusion. Okay, so specific latent heat, so it means specific latent heat, the amount of heat required, right, to change phase, right, without change of temperature for 1 kg of substance. Okay, so the changing of phase means from solid to liquid or liquid to gas or gas to liquid or liquid to solid, right? So that is the change of phase. Okay, but the important thing is there's no change in temperature. So if you look at this graph, okay, so here, right, so fusion, so sorry. Alright, so fusion actually is, okay, fusion is from solid to liquid or liquid to solid, right? So mean it as at this part, right? So this is specific latent heat of fusion, okay? This is specific latent heat of fusion, okay? Alright, so if you want to find the value of specific latent heat of fusion, that is L, okay? So what formula that you should use is PT is equals to ML, right? PT is equals to ML. So PT is what? PT is actually the electric energy, okay? So means we assume the electric energy that's supplied by the emission heater, okay, is used, okay, to change the phase of the substance here. So this one from solid to liquid. So mean there is no heat energy lost to the surrounding, right? So this one we use the principle of conservation of energy. So we assume that electrical energy is same as the heat energy used to change the phase, right, from solid to liquid. So the P here is actually the power, okay, not the voltage. Okay, so the power here is 1 kilowatt. Okay, so I change the prefix first, right? Kilo is 1 times 10 power of 3. Okay, and then the time here, so you can see 1 until 2.6 minute. So you just minus, so for this part you got 1.6 minute. Okay, we have to remember the time here must be in second. So you multiply by 60. Okay, and then the mass of it already given 0.02. Okay, and then you find the L here. Okay, so use your calculator, so you got the answer 4.8 times 10 power of 6 jkg negative 1. Okay, so this is the answer for C1. Okay, so for those who got it correct, so good. Okay, alright. Okay, let's say for C2. Okay, the specific heat capacity of the substance in liquid state. Okay, so you know this is solid. Okay, so solid plus liquid, and this one is the liquid base. Okay, so let's try. Okay, I'll let you try first. Okay, can erase your whiteboard if you need my help. Okay, I can erase for you too. It's better for you to try because before this, I just give you the answer directly, right? So I'm not sure whether you understand or not. So now I want to see first whether you can answer or not, that I will explain. I think this one is better. Okay. It's okay, just try. If you got it wrong, it's okay. Please push the board. Actually, I don't use the board because you have the book already with you, right? So you can just see the question on the book, then you write your answer in the board. Okay? Because this one I don't think I need to push the board to you because all of you already got your board automatically, right? I don't have to push the board for you. Unless if I have a question, okay, then I will push the board to you. But now you already got the book, you can see directly the question on your book. Okay, page 103. Okay, the module that I give to you, right? The tick one, page 103. The question is there. So that's why I don't push the question to you. Right, PT, MC, theta. Okay. Um, 39344. Okay, good. Okay, when you answer, when you calculate, right, and you give the answer, make sure the answer, I prefer the answer in the standard form. Okay, so like example for like this one, yeah, like this, like so. Okay, change to standard form. So the answer like this. Okay. If you don't change also it's okay, but I think it's better for you to change to standard form. Okay, and you can take until 2 or 3 decimal point. Okay, and make sure, okay, your answer no fraction. Okay, no more fraction please. Okay, okay, so let's see the correct answer. Okay, alright, so for this one, okay, so the specific heat capacity of the substance in liquid state, so this phase, right? Okay, so same, we assume that the electric energy is equals to amount of heat energy, right? For the heat specific heat capacity, MC theta. Okay, so power 1 times 10 power of 3. Okay, but time here is 3.6 minus 2.6, so you got 1 minute, right? So change to seconds, so multiply by 60. Okay, M is still 0.02. C you need to find. Okay, and then the theta here from 78 to 200, right? So theta is actually the change of temperature. So you have to minus 200 minus 78. Okay, and then you got C. Okay, so you got C is 2.46 times 10 power of 4. Okay, so the unit is JKG, negative 1 degree Celsius, negative 1. Okay, if you're not sure about the unit, you can just leave it. Okay, if you're not sure about the unit, you can just leave it. Okay, so that's the answer for C2. Okay, so I hope you can understand. Okay, right. So let's move on to the next slide. Okay, for D. Okay, so diagram 11.3 shows the arrangement of the apparatus to determine the specific heat capacity of aluminium block. Okay, so table 11.4 shows the material that are able to use in the arrangement of the apparatus. So you are assigned to investigate the material shown in the table 11.4. Okay, so this is the experiment, right, to determine the specific heat of capacity. So when it comes to experiment, okay, there's one principle that you need to remember for this experiment. The heat is not allowed to be transferred to the surrounding. So whatever you choose, there must be used to preserve the heat, right? So not allowed the heat to transfer to the surrounding. Okay, so for this one, okay, so the set of apparatus P, Q, R, and S. Okay, for the plate X, of course you have to use the asbestos, okay, because it's a good conductor. Okay, and so the explanation we can say prevent loss heat to the surrounding. You can say asbestos is the good insulator. Sorry, not good conductor, good insulator. Okay, you can say for that for the explanation. Okay, for the liquid white, you use oil, okay, because it can transfer heat uniformly. Okay, you can see we put oil here, right? We put oil here. Okay, and then the next one, okay, metrizate is a cotton. Okay, so this one you can use the first reason, the first explanation, right, to prevent the loss heat to the surrounding. Okay, and then for the power of emission heater, okay, so high power of emission heater, so can provide high heat energy. Okay, so the last one I choose Q. Okay, because okay, it use asbestos, oil, cotton, and also has a high power of emission heater. Okay, so this is for question 11. D. Okay, answer for question 11. D. Okay, so now we go to the next chapter, chapter 5. Okay, light. Okay, for chapter 9. Okay, so we just discussed for this one. Okay, so the diagram one shows a girl is combing her hair in front of plane mirror. Okay, so what is the phenomena involved for a plane mirror? Okay, so the answer should be reflection of light. Okay, so remember mirror use reflection. Okay, but for lens they use a refraction. Okay, refraction of light. Okay, so the next one, okay, tick at the correct box. Okay, so the law of refraction state that angle of incident is equals to the angle of angle of reflection. Okay, so the answer should be this one. Okay, equal to the angle of reflection. I is equals to R. Sorry, not C. R is equals to R. Right? For C, based on diagram 1, okay, state one characteristic of the image form. You can choose this one of these three answer. Okay, virtual, same size as object, laterally inverted. Okay, so because the question was one only, remember, just write one only. Okay, don't put more than one. Okay, just put one only. Okay, so if alright, so next we move to the next question. So given the initial distance a girl in front of the mirror is 40 cm. Okay, so if the girl move at the distance of 50 centimeter backward, okay, so what is the distance between its image and its mirror? Okay, so let's say we have a mirror here, okay, and then the girl is standing here, and then the initial is 40 cm. Okay, so it said here if the girl move at the distance of 50 centimeter backward. Okay, so mean it move more 50 centimeter backward. Okay, so now it's the new position. So now it will be 90 cm, correct? The image, the distance of the girl and the mirror is 90 cm. So the image also should be 90 cm, okay, behind the mirror. Okay, so now they're asking you what is the distance between each image and the mirror. So the answer should be 90 cm. Okay, because you know for the plane mirror, the image, the distance of the object between the object and the mirror is same as the distance between the image and the mirror, right? So should be same here. Okay, so the answer should be 90 cm. Okay, next one. Okay, diagram 9.3 shows a crew of submarines seen through a mirror periscope, right? So the ship looks small and blur in view. So you are required to suggest a suitable modification to make the image of the object become sharper and bigger. So state and explain your suggestion based on the characteristic of material for the body and additional features for the periscope. So periscope actually they use the phenomenon total internal reflection. Okay, total internal reflection. Okay, so the first one, okay, for the body of the periscope, so we use a steel, okay, long lasting, okay, and then you know for the total internal reflection, right? So they have to use a prism, okay, and the angle for the prism should be 90, 45, 45, okay. Okay, 90 degrees, 45, 45. So this is the angle for the prism that we use in the periscope. Okay, so 90, 45, 45. So at this angle, okay, the total internal reflection will occur. Okay, alright, so use a prism, so total internal reflection will occur. Okay, and then we use a convex mirror, so to produce the bigger image. Right, and then we use the big diameter of lens. Okay, so this one is to allow the more light to enter. Okay, some of you okay ask me what does it mean by big diameter. Okay, so this is the lens. Okay, so diameter is actually from here to here. Okay, so this is a diameter. So when the big diameter, so mean you allow more light to enter the lens. So the lens will become more brightened. Okay. Alright, and then the inner part, okay, black color. Okay, so this one is to absorb the light that fall at the wall of the periscope. Okay, sorry for the um, okay, so this one to absorb the light that fall at the wall of the periscope. Okay, so I hope you are clear. Okay, how you want to uh, modify, right, the periscope. Okay, for this question. Right, so we move on to the next one. Okay, so diagram 11.1 shows a magnifying glass, okay, used by the forensic officer to study a fingerprint trace. Okay, so what is the mean by focal length? Alright, before that, magnifying glass is actually they use a convex lens. Okay, so they use a convex lens, and the object is before F. Okay, so mean if you have a ray, you want to draw a ray diagram here, right? So the object should be here, okay, before F. Okay, then you can produce the visual and magnified, right, image. Okay, so the first question, what is the mean by focal length? So the focal length is distance between focal point here, right? Focal point here and the optical center of the lens. So this is the optical center of the lens. Okay, so this is the optical center of the lens. This is called as a focal point. So here, from here to here, okay, I use another pen here. Okay. Okay. From here to here, this is called as a focal length. Okay, focal length. Okay, and this is called as a optical center. So this is focal point. So this distance we call it as a focal length, right? Okay, and then next one. Okay, so you are given a convex lens. So by using the other suitable apparatus, so describe how the power of lens can be estimated. So this one is like you doing the experiment, right? Okay, so the first one you have to use the convex lens. So the convex lens is aim, okay? You focus the convex lens to a distant object, okay? And then after that you adjust the screen, okay? Adjust the screen until a sharp image is formed on the screen, okay? And then after that you measure the distance between the screen and the lens. Okay, so using a ruler you measure. Okay, now the measurement that you get is actually the focal length. Okay, and then after that you can see here, right? Use formula. Okay, use formula. P is equals to 1 over F. Okay, to calculate the lens power. Okay, so use formula P is equals to 1 over F to calculate the lens power, because the question asks you to find how to find the power of the lens. Okay, so after you get the F value, right, from the experiment you have to state, right, what's the formula you use to find the power of the lens. Okay, and you have to remember, okay, for the convex lens the power must be positive. Okay, the power must be positive for the convex lens. Okay, and for the concave lens the power must be negative. Okay, and also for F, okay, F for convex lens is positive, for concave lens F is negative, the focal length. Okay, so this one you have to remember, this is the sign, right? Um, the signs for for the lens, right? When you calculate, so this is the sign you have to remember. Okay, so positive for convex lens and negative is for concave. Okay, so let's say you should go to check your eyes, right? At the optic, for if you want to make a new specs, they have to check your eyes first, right? And then they give you a piece of paper and they state like positive 0.07 D, correct? So you know if positive means that one have to use a convex lens. Okay, and D is actually the unit for power, for the lens power. Okay, D is diopter. Okay. Okay, next we move to the next question. So you are required to investigate the characteristic of the magnifying glasses as shown in table 11. Okay, so percentage of light transmitted, type of lens, okay, focal length and also the diameter. Okay, so the percentage, okay, so you have to remember I already told you before the magnifying glass they use a convex. Okay, so the first one is high percentage of light transmitted. Okay, so this one to produce the brighter image. Okay, and then have to use a convex lens. Okay, because convex lens can produce virtual bigger image. Okay, and upright. Okay, and then shorter focal length. Okay, so this one is to produce the virtual bigger image and upright, okay, and then the high diameter, okay, or big diameter. So this one to allow more light to enter. Okay, so the answer should be I choose P because high percentage of light transmitted, okay, convex lens, and also they have a shorter focal length and also high diameter. Okay, so this is the answer for magnifying glass. Okay, alright, for this one, I want you to calculate. Okay, for D. D1, D2, and D3. Okay, so I give you a formula. Okay, for number 1, you can use M is equals to V over U. Okay, and for number 2, you can use the length equation. 1 over F is equals to 1 over U plus 1 over V. Okay, and then for number 3, so this one, the formula, I just told you before, P is equals to 1 over F, and F must be in meter. Okay, so I give you the formula already. You can try to find the answer for D1, D2, and D3. Hmm. Don't forget if you already find the value, right? 1 over F, okay, so you have to change to cross multiply to find the F. I noticed some of you, you change the V and U. Okay, for the question for D2, right? You change the value of U and V to meter when you want to find the F. Hmm. Okay. Most of you got it correct. Hmm. Hmm. Okay. Good try. Right. So, okay. So let's see the answer. Whether the answer is correct or not. So, but what I see here, most of you got it correct. Okay. Alright. So let's see the answer. Hmm. Okay, for number one. Okay, for number one. um, Okay, for number one. Okay, the linear magnification of image M. So I already told you M is equals to V over U. Okay, so V is actually the distance of the image from the optical center. So from here to here. Okay, so this is V. Okay, so means you want to find the value of V is 45 minus 15. Okay, so you got 30. Okay, and then for U is the object distance. Okay, the object from the object to the optical center here. Okay, so this is U. Okay, so this is called as U. Okay, and then you have just divide. Okay, 30 divide by 15. Okay, so you got 2. Okay, for magnification, okay, for the linear magnification, you don't have to put the unit. There's no unit for linear magnification. So this is the answer. Okay, so this is one of the formula for if you want to find the linear magnification. Okay, other than that, you can use HI divide by HO. Okay, so what is HI? HI is actually the height of the image here. This is HI. Okay, and then HO is the height of the object is here. HO. Okay, so you can use whether this formula or this formula. So this depend on the info that given by the questions. Okay, you can choose one, or sometimes you can use both. Okay, like this one. VU is HI divided by HO. Okay, you can use this one too. Okay, so it depend on the question. Okay, alright. So this one the answer is 2, correct. Okay, so let's see for number 2. Okay, for number 2, the focal length. So you use the 1 over F is 1 equals to 1 over U plus 1 over V. Okay, some of you change to meter, okay? So it's okay. If you don't want to change also, it's okay. Alright, so 1 over u is actually 1 over 15. Okay, and 1 over v is 1 over 30. Okay, so you use your calculator, you got 1 over 10, right? Okay, so actually F is 10 cm. Okay, after you got this one, you have to cross multiply. So the answer for F is 10 cm. Okay, and then for number 3, okay, so the power of length, so P is 1 over F. Okay, so F, since this one is a convex lens, so actually the F is a positive value. Okay, because this is convex lens. So 1 over 10. Okay, so 1 over 10. Okay, but this one you have to change to meter first, correct? So 1 over 0.1. Okay, remember F must be in meter. So you divide 1 to divide by 0.1, you got 10D. Okay, and don't forget to put the positive sign. So means this is the convex lens. Okay, so positive 10D diopter. Okay, so I hope you are clear for this question. Okay, so this formula, I'm not sure whether they give or not, but this one I think they give. Okay, but this one I'm not sure. So just remember the formula. Okay, sometimes they give you the formula that actually cannot be used at all in the question. Okay, so as a safety, okay, so please remember all the formula that you need to remember, okay, in physics, okay, that will be used. Okay, next we move on to the next question. Okay, so this is the diagram 7.1 shows the structure of the rev reflector of a bicycle created by a student. So the reflector consists of identical plastic prism which has a critical angle of 42. Okay, so what does it mean by critical angle? So critical angle is the angle when is the incident angle when the refraction angle is 90 degrees. Okay, so this one I already told you, right? Okay, so let's say this is a normal line. Okay, if let's say here is 30 degrees, okay, and given you the critical angle is 42 here. Okay, so let's say the incident angle is 30, so I is smaller than C. So when I is smaller than C means there will be the refraction, right? So refraction, it will refracted away from the normal. Okay, because you already know for the total internal reflection to occur, they must be from the denser to the less dense. Okay, to the less dense object. Okay, to the less dense object. Okay. Okay, so denser to the less than, of course, is refracted away from the normal. So it will refracted away from the normal. Okay, and then they say if I keep increase the angle, okay, keep increase the angle until it's same as the critical angle here. Okay, so let's say this one is 42 degrees. So this is the incident angle. Okay, and then you already know the critical angle is 42. So means at this time I is equals to C, correct? So when I is equals to C, okay, so the refracted ray will at the boundary of the glass here. So this will be the refracted ray. Okay, so the angle of refraction here is 90 degrees from the normal. So here we call it the I here, the 42 here, 42 degree here is we call it as a critical angle. Okay, so the incident angle when the angle of refraction is 90 degrees. Okay, so let's say if I keep increase more than 42 degrees, let's say 50 degrees. So what will happen? total internal reflection will occur. So means all the light ray will be reflected back into the glass. Okay, so at this time I is bigger than C, total internal reflection occur. Okay, so this is total internal reflection. Okay, I explain again. Alright, so the next one, okay, for this one, okay, I want you to try to draw. Okay, so I want you to try to draw the reflection, the ray, the light ray for this one. Okay, try to draw it. Okay, this one I will push the board to you. Okay, right. Okay, try to draw. Hmm. Okay, the first one you have to know whether there will be a total internal reflection will occur or not. Okay, you have to see the incident angle. So the incident angle is you can see from the question, right? The incident angle is 30 degree, correct? And then the question gives you the critical angle is 42. So whether there will be internal reflections to occur or not, so you have to see the incident angle and also the uh, critical angle being given by the question. Okay. Hmm. It's good, most of you got it correct. Okay, but the light ray cannot pass through the, yeah, it cannot pass through until it's go out like that. Go out from the, okay. Okay, some of you got it correct. Good. Right, so okay. So for this one, okay. So for this one, you already know that I is 30, correct? And the critical angle is 42. So means I is smaller than C. Okay. So when I is smaller than C, of course there will be a no total internal reflection will occur. Okay. So what will happen? It's actually a refraction. Okay, so refraction. So since it's come up from the denser to the less dense, okay, so should be refracted away, okay, away, okay, and then it will be reflect back, okay, to the next, okay. So this is the uh, ray diagram for this diagram 7, okay. This is how you draw. Okay, it will reflected away, okay, from the normal line, okay, but it will reflected back, okay, right. Because this one is a transparent plastic cover, so the light will, okay, reflected back, okay. Okay, so let's see next one. Alright. Okay, based on diagram 7b, okay, what happened to the light ray after entering the reflector? So the refraction of light will occur, okay, because the incident angle is smaller than the critical angle. Okay, so for this one mark, okay, and then you state this one is 1 mark. Okay, alright, for the next question, okay, based on diagram based on the observation in 7b2, the student found that a few modifications should be made so that the reflector reflects more light. So the modifications are based on the following aspect. So this one I already tell you, for the total internal reflection to occur, the angle of the prism must be 90 degrees, 45 degrees, and 45 degrees like this. Okay, like this, 90 degrees, 45, 45. Okay, you can draw or you can just take the angle there. Okay, and then for the reason is for the total internal reflection to occur. Okay, and then the number of prism should be high number of prism, so there will be more light will be reflected. Okay, alright. The next one, okay, this one I want you to calculate. Okay, so using your board. Okay, using your board. Okay, try to calculate. You can just calculate at the empty space that you got in the board, no need to erase. Okay. Before I forgot, please take attendance, okay? For Elvin 5K, Ying Hui 5M, and 5E Jayan. Okay, please take the attendance. What is the formula for the refractive index for total internal reflection? There is n is equals to 1 over sine C. Okay, n is equals to 1 over sine C. C is what? C is the critical angle. Okay, make sure that you give the value until 1 or 2 decimal point. Correct. 1449. 1449, good. Okay. 1449. 1449. Yes, very good. Okay. So let's see the question. 1 over sine 42, correct? So you got 1.49. Okay. Alright, for the next question is state the type of lens. So this is convex lens. Okay, convex lens. Okay, and the next one, mark the focal length for the lens on diagram 1.1. So the focal length should be from here to here. Okay, and then you have to mark it with F. Okay, mark it with F. Like that. Okay, right. So the next one, okay, so this one I just discussed, okay, because you already know how to calculate the power of the lens, right? Okay, so the power of the lens is just P is equals to 1 over F. Okay, and then F is actually, okay, 20 cm, right, from here to here. So if you just want 1 F here, so you just divide by 2. So you got 10 cm, but you have to change to meter, right? So 1 divided by 0.1. So you got 10 D. Okay, and then this one is a convex lens. So should be positive 10 D. Okay, positive 10 D. It seems that the question we answered before. Alright. So I hope you can understand, okay, more, okay, about how you want to answer the right questions. Okay. So we continue. Okay, we continue maybe next week on this Friday. So I will see first. Yeah, I'll tell you if anything. Okay, so thank you, class. Welcome.